Welcome to Green Giants, Titans of Renewable Energy, the podcast where insights and innovation meet. Every episode, we dive into conversations with industry leaders, experts, and change makers, bringing you the stories and ideas in the renewable energy sector that shape our world. And now, let's jump into today's episode with your host, Wes Ashworth.
Welcome back to Green Giants, Titans of Renewable Energy. Today's guest is Eugene Beh, founder and CEO of Quino Energy, a company working on one of the most critical challenges in the energy transition, how we store energy at scale, affordably, and for long durations. Quino is building organic flow batteries powered by quinone-based electrolytes with a fundamentally different approach to costs, materials, and manufacturing at a time when the grid is being reshaped by renewable generation, electrification, and rapidly growing demand. The question is no longer whether we need storage, but what kind of storage is needed. This conversation explores the intersection of chemistry, industrial manufacturing, and energy infrastructure, and what it really takes to move from breakthrough science to something that can operate reliably in the real world. With that, Eugene, welcome to the show.
Thanks, Wes, for having me on. Really happy to be here.
Yeah, thrilled to have you on, thrilled to get into some of these topics. And as we always do, we'll start a little bit with your journey to kind of get to know you a little bit. So what initially drew you into energy storage and what made you focus specifically on flow batteries?
Well, it's a funny question to ask because I did grad school, and in grad school, I did a PhD, right? And usually your projects in the university don't really have much practical bearing on something that could become a product. They're kind of far removed, right? So it was really driven by, I really want to work in an industry that is kind of future-proof, right? And which is kind of at the forefront of one of the mega trends. So energy storage, it's one of those things which is pretty much unstoppable these days. It kind of feels like social media at the turn of the century. You knew something big was going to happen, right? You want to go catch that wave. So just so happened that I worked with something kind of similar. So why flow batteries? Well, I knew that these were my skills. I wanted to do something in energy storage which used these skills. So I deliberately looked up and joined Harvard University working on this exact technology that we spun up.
Yeah, it's super cool. And as you said, kind of energy storage is that next big wave. I love that the analogy there, sort of like caught the wave and got in. Energy storage sits at this like intersection of physics, economics, and infrastructure. People tend to come in the industry from very different doors. I always love to hear those different avenues. What was the moment, I guess, specifically when you realized quinone-based electrolytes could be the foundation of a new kind of battery company?
Well, there wasn't just one eureka moment, actually. It's actually the culmination of many people's hard work, not just mine. The big thing was essentially all comes down to two things, right? First is cost and lifetime, and lifetime is really just a cost number at the end of the day. And back then, we knew that it will be cheap, but it didn't last very long. When I was working on it, so I did spend 5 years in the industry between my postdoc and actually starting Quino Energy. But when I was there, I discovered a way to make something last for a really long time, and that kind of solved one problem. But then it turned out that making these chemicals, which go into the tank of flow batteries, will be too expensive. So it's like, we looked at it real closely and then decided that this could be commercialized. Well, it turned out later on, a couple of years in, when I'd been in the industry for a bit, people found a way to go and kind of reverse the degradation of really cheap materials. And then, we realized, okay, we're onto something. I kept in close contact with my former team at Harvard, and when there was that breakthrough, they actually called me up and said, hey, will you be interested in leading Quino Energy? Because I was doing something very similar to that at my time in the industry.
Yeah, it's one of these really cool things. It's one of the things I love most about this space. You kind of see these like kind of breakthrough moments, these people getting started in these companies and scale and grow it. It's just really exciting stuff. And I know, like, before we go deeper, I want to level set on the technology itself, because I'm sure listeners are going, what are we even talking about right now? This is an area, like a small shift in understanding really changes how you see the entire storage landscape. So for people maybe hearing this for the first time, let's start just a little bit of the basics. Like what is a flow battery and how does it differ from something like a lithium-ion battery?
Yeah, absolutely. So, like any kind of battery is really a chemical reaction. And at its heart, you have, I like to use the analogy of a car, a gasoline car. You've got the car itself, you've got a fuel tank, you've got an air intake, and then fuel is combined with air or oxygen in the engine, and you burn that get energy out, right? So all batteries are really like, a fuel and an oxidizer reacting and giving you electrons, electricity. A flow battery actually is very similar to a vehicle in that, I've got 2 tanks of liquid, 1 tank of liquid fuel, and 1 tank of liquid oxidizer. These are not like gasoline or anything. These are special chemicals that can be converted from like the charge state to the discharge state, or in reverse as well. So essentially, you've got 2 tanks of liquid, the fuel and oxidizer, and then they get pumped to a flow battery stack, which you can imagine it as something like the engine of a car, but you can discharge the energy, get it out, or you can put energy into the engine and then kind of regenerate your fuel and oxidizer. So it's as though, your car, right? You can drive it, but then also you can bring it somewhere, and then there's something which spins the wheels and makes your gasoline back, something like that. So that's what a flow battery is.
Yeah, I love that. It's kind of like simple analogy. Definitely paints a picture, helps you really get your head around it. At a high level, how do quinone-based electrolytes function inside of a flow battery system?
So the most commonly used electrolyte, which is the electrolyte, just the liquid in those tanks. The most commonly used thing is vanadium, which has been deployed on gigawatt-hour scale right now. But it's expensive. There isn't that much vanadium, and usually you have to mine it together with other things and separate it and purify it. So we're actually using exactly the same architecture as a vanadium flow battery, but we've just replaced the liquid with something which is made essentially from coal tar chemicals. That's the quinones actually. You're probably wearing some coal tar chemicals right now. And in fact, it's just a 1-for-1 replacement, and it's got the same performance, and but it's a quarter of the cost. So that's essentially it. It's like, going back to the car analogy, it's like, let's say I discovered a way to go and make gasoline for a quarter of the cost, right? It will definitely sell like hotcakes. But you can use the same car. You don't need to do any kind of conversion.
Yeah, that's fascinating. You're kind of seeing this come together of what this could be. So we'll continue to get into it. What advantages do quinone-based systems have compared to, as you mentioned, sort of the typical vanadium flow batteries, or even lithium-ion, when you think about cost and scalability?
Yeah, so let's talk about lithium-ion first, because I mentioned vanadium a little bit just now. I'll come back to that later. With lithium-ion is great, right? It's been commercialized and it's like widely available. But I think a big difference is like, first, it's cost. We think that our flow battery chemistry will allow flow batteries to actually compete with or even be cheaper than lithium-ion. That's one thing. But second is also flammability. Not just us, but other flow batteries, generally the reactants, the electrolytes are dissolved in water, which means that they're completely non-flammable. That's totally unlike lithium-ion. But the catch is that it's really heavy, right? So a lot of water also means a lot of thermal mass, which is a good thing, but also means a lot of just weight. So it's okay if you're using this for energy infrastructure, like the grid, but definitely not in electric vehicles, unless you want your car to have like 20 miles of range. Yeah, I won't recommend it.
Yeah, absolutely. It's great to think about it, kind of comparing those 3 different materials and kind of how that all works and what it's right for and whatnot. I'll get to this, maybe ask it a different way in a bit, but in terms of like, what is the advantage of when we think about, okay, so most people highly familiar with lithium-ion. We're talking about flow batteries and then, vanadium, quinone-based. Like, when does it make sense to use more of that flow battery versus a traditional, lithium-ion or another technology?
So there's actually a few considerations, right? In the like grid scale storage space, really the only thing that really matters is cost. That's I think the biggest driver for everything. And so you just need it to be cheaper. And we think that, if you're producing our electrolytes at gigawatt hour, like single gigawatt hour scale, the cost will be actually about 15, maybe 20% lower than lithium-ion. And then there's additional cost savings when you think about something like installation, which today it's actually like the same. It costs as much as the entire battery capex, if not more. And that's actually another place where our technology can get additional cost savings and kind of differentiate ourselves from lithium-ion or other kinds of flow batteries. We'd be able to repurpose like really big steel tanks for storing gasoline or lubricants or whatever, and use those as flow battery storage tanks. And then, I don't need to go and build a new tank. I don't need to pour a giant concrete foundation. I don't need to like get permits to store hazardous chemicals because it's already doing that. That's an additional innovation besides just capex, which will allow you to get more cost savings, for total install cost over lithium-ion. It's probably better from a community acceptance point of view, because people are like, oh, I don't want this new thing built. Oh, if the big tank is already there, no one's going to say anything if the inside has been replaced with another liquid. And then going on to one other thing besides cost, which is like flammability. I think everyone has probably heard about the Moss Landing battery fires, plural, right? It's happened more than once already. And one could say that, fires or fire safety, that's just an insurance cost that all gets rolled up into the overall cost of the system. But what people really hate is that if there's a fire in their neighborhood, every elected official is going to get a whole bunch of phone calls and negative press, and people asking difficult questions, and nobody wants that at all. You can kind of hedge that with insurance or something, but at the end of the day, we're seeing lots of community opposition to potentially flammable battery installations too, and going to flow batteries kind of lets you dodge that.
Yeah, absolutely. So you've got some clear advantages there. I mean, obviously you talk about from a material standpoint, more readily available, less involved there, using some existing infrastructure, performance, obviously safety. I mean, there's lots of advantages we're starting to uncover here as we talk through it. Thinking about where flow batteries are today, if you look over the next decade, where do you see them fitting into the broader energy storage landscape? Like, what does that look like 10 years from now with that trajectory?
So flow batteries are coming down in cost. I think lithium-ion is kind of getting stable already. Costs still falling, but not anywhere as fast as they had been. And now I think it's time for flow batteries to shine. So, looking 10 years in the future, I think it's pretty clear to me and other people in the industry too, that like vanadium today won't actually allow flow batteries to stay relevant in the long term. I mean, apart from some niche cases, right? Like, you could think about basements or places where no matter how cheap lithium-ion gets, you can never install those. But, obviously we want it to be mainstream, and the larger the deployments, the cheaper the unit cost too. So we really want to get that virtuous cycle going. I think you will see, a good fit with places where you just cannot tolerate the virus. And second, now everyone's talking about like AI data centers, hyperscalers, right? Those things actually require multiple cycles per day, and that's actually one place where flow batteries really shine, is that they have really, really, really good cycle life. The lifetime of a flow battery is not affected by how many cycles you put on it. That's not unique to us. That's the same with vanadium as well. Imagine your cell phone battery, right? You use it after 3 years, like, it's terrible, right? And the lifetime gets worse when you do more deep cycles. Like, you probably won't do deep cycles on your EV in case you get stranded on the roadside, but you won't think twice about your phone running out of charge, like just plug it in anytime. But yeah, that's one place. On one side, you have short duration flow batteries. If you're familiar with flow batteries, this seems a bit unusual. But short duration, multi-cycle per day flow batteries will be one aspect where it could really shine. And the other is long duration energy storage. And in flow batteries, the engine is the expensive part. The fuel, the liquids, the electrolytes are not. So if you want to minimize cost, you want to go for something where your engine is small and the fuel tanks are huge. And that's LDES, right? Long duration energy storage. I think like you see those two niches being filled by flow batteries in the future.
Yeah, absolutely. And you mentioned sort of data centers being a good application. What are the other major applications you're seeing the flow batteries used in? You mentioned obviously data centers being a good fit. Are there other kind of main ones where it's just like, yeah, this makes a ton of sense to put a flow battery here?
Yeah. So data centers are the one extreme where it will probably favor short duration flow batteries. And then on the other side, you just have, as you install more batteries, more energy storage, more renewables on the grid, the requirement for the duration storage is longer and longer. So I will even say it's like that specialized on the other side, of the longer duration side. It's just like wherever you are citing batteries now for grid storage, that's where you find flow batteries would be great for. But in the short term, like something that needs really long duration energy storage or resiliency, probably more rural communities, places like California especially, and also places where it's just like really, really difficult to bring in fuel, so I would say like army bases, for example, islands such as remote communities or like the Maldives or someplace like that. That would be a probably a good one because number one, it won't catch fire. So, if you're on an island and your lithium-ion battery catches fire, I think you're going to be in real trouble. So yeah, or just from like a operational security point of view, like if you have a big fire in an army base, that's also really bad, right? And then you have everyone just calling up the electeds and complaining, and like nobody likes that.
Not at all. So we've covered a bit of just like kind of understanding the technology overall in a kind of basic sense. The real challenge is once we understand the technology, but turning that into something that can be produced and deployed at scale. And I want to get into that. So your approach centers on producing quinone-based electrolytes using a continuous zero waste chemical process. Tell us about that. Like, what does that look like in real practice?
Yeah, it's actually pretty nice. You just turn on the taps and the liquid just comes out of the production line, and you just keep on filling up the tanks. That was actually what was holding us back at the beginning. It's like, okay, you can come up with a brand new battery material, right? A new electrolyte, but how do you produce it? And how do you produce it scalably and cheaply enough that it can actually like be something that people buy, right? Because it's affordable enough. I would say so. Our system basically, you just take two reactants. One is a dye intermediate. It's this orange brown kind of dye, which is readily available. People start making it like more than a century ago, and then we put in another reactant, which is called glycolic acid. That's actually I think widely used in the cosmetics industry. We mix them together and then put it actually through an electrochemical reactor, which is essentially a modified flow battery stack or power module. And we give it a little tickle with some electrons. And, that's like the third ingredient in the recipe. There, they all just react and then it comes out fully converted, ready to use. And I don't need to clean it up. I don't need to purify it. You can just use it directly in the flow battery. And so it's a continuous flow process where you just put in electricity at the two chemical reactants and out comes the product. Ready to use, and it's really nice, really clean, and the only byproduct is oxygen gas, and so it's something that we're really proud of.
Yeah, it's incredible. I think manufacturing is often where the real moat is built, not just in the chemistry itself, and I think that shift from sort of batch to continuous processing tends to separate what can scale from what stays in the lab. So it's cool, those innovations. How important is the ability to leverage sort of existing chemical manufacturing infrastructure in scaling your production?
Well, actually, that part is not so critical for us because the nature of our process, the existing chemical production infrastructure is kind of like, it's pretty standard. You can find this in hundreds of places around the world in the country. And so, like things like how do I dump solid out of a bag and like how do I pour it into a tank, that is all really standard. But what's really nice is that our process, this electrochemical reactor that I mentioned, is actually really small. It's really compact. In fact, earlier this week, we just took delivery of a reactor which can make 800 tons a year, or about, I want to say like 120 megawatt hours per year of electrolyte. And that only has the footprint of a 20-foot shipping container. So it's really small, really compact. And that's because it's a continuous flow kind of process. Like stuff goes in, products come out. It's really nice. But, I want to say like all the raw materials are can be sourced domestically as well. I didn't really mention that earlier, but it's a really nice thing because now you can actually truly get something which is substantially like a battery which is substantially produced in the United States or whatever other country you want to deploy your batteries. And that part's really nice.
Yeah, it definitely really nice. Definitely so many different parts there that help you just make this scalable and make it a little bit more simplistic in a way where you're having these huge footprints and all this other stuff and this major infrastructure and what have you. As you've gone, so what have been like the most important breakthroughs or inflection points that made scaling your quinone-based electrolyte production actually work?
Yeah, I think it was when we discovered that the product coming out was actually even more pure than the standard than the standard chemical process that needed you to clean it up and all that. So at first, when we first got started, we thought, okay, I know what I want to make. I come from like kind of chemistry background, and every time you make something, you have to go and purify it. And we knew we had to purify it using these organic solvents. And it turned out that when we tried the electrochemical method, it was like, whoa, this is actually good enough. And this is all happening in water, by the way. So I don't need any kind of organic solvents or volatiles or anything. And then we discovered, you know what? You can kind of see the gears kind of turning in our heads. We're like, wait a minute now. This is going to be really, really simple because I could just like fill up tanks directly. I don't even need to clean it up. This will save me a whole bunch of money and a whole bunch of headaches as well.
Yeah, again, huge advantages there. It's cool to see those like breakthroughs and those little moments, those aha moments that happen as you go and go down the process. In case we didn't make it abundantly clear, I do want to go back, then I'll move on to the next section here. When we think about, we talked a little bit about flow batteries. You're using a quinone-based flow battery versus vanadium. Tell us a bit more about like those that don't have a chemistry background, like what is a quinone-based battery? Like, where does it come from? What is it? How does it work? How is it better than vanadium? You've covered this a little bit. I just want to make sure we fully get it.
Yeah. So actually, there was a lot back there that I hadn't mentioned as well, right? So how does it work? Well, just like vanadium, certain chemicals can be reduced or oxidized. It's like if I burn gasoline in a car engine, obviously I'm oxidizing it, right? But if I turn carbon dioxide back into fuel, that's like process of reduction. It just takes it gives up electrons respectively, and you just have some kind of carrier, whether it's a vanadium ion or it's an organic species like a quinone. Those things can give up or take in electrons, and that's how they can function. One thing I didn't really mention, I think you mentioned like repurposing chemical production infrastructure, but actually what's more enabling is we're able to use flow battery hardware originally built for vanadium with minimal modifications with our electrolyte. So, going back to the car analogy, right? I've got a new fuel, but I don't need to make a new car or a new engine. That I think really simplifies the scale up, because like other people who are doing battery startups, they had to sink a lot of money into scaling the rest of the manufacturing. For me, if you made a new fuel that works great in a gasoline engine, well, I'm not building my own car, right? I'm just going to buy a Toyota and put the fuel in there. So it's kind of the same thing for our technology, where I don't need to go and build the rest of the system. Actually, we are partnering with a lot of other firms who are building like the rest of the car, so to speak, and using our liquid in those tanks. So I don't need to manufacture batteries and all the control systems. I just need to just focus on making one chemical, which really simplifies things and allows us to work like very lean. And that's a good thing for a startup. We can move really fast too.
Absolutely. I appreciate you clarifying on that. I wanted to make sure we covered that. And as you're saying, like huge potential there. Somebody that's using a flow battery now with a vanadium, base, it's easy for them to transition and switch over to this quinone based, which again, you've talked about, material more readily available. We're talking about cost implications, all these sort of things. That's huge versus having to like, again, sort of build out a whole new infrastructure and redo all this sort of thing. Kind of compared to like, a gasoline to hydrogen engine. You can't use the gasoline engine and just put hydrogen in, it's fine. In your case, when you are talking about an existing flow battery system, you can, and just switching over the material, which is incredible.
So, it's like I invented gasoline that I can produce and sell for $2 a gallon, right? Everyone is going to line around the block to get that.
That's a great analogy. That really puts it in perspective. And again, that's what this is. So that's phenomenal. So we've talked a little bit about kind of the scale up in manufacturing. I think even if you solve manufacturing, which you have, the technology still to perform reliably inside a full system operating in the field. So what have you learned about how electrolyte chemistry impacts just overall system performance, especially over long durations?
Yeah. One key factor about flow batteries is that the degradation is excellent. Like with vanadium, it doesn't go bad. You might have to like recondition the battery every now and then, but it doesn't go bad. With organics, they do degrade over time, but that's actually like our degradation rate is still lower than lithium ions anyway. So I don't think that's really a big deal. The nice thing is that vanadium flow batteries, so it's not just the liquid, right? The rest of the system, vanadium flow batteries have already been in operation in the field for decades. So we're kind of like leveraging that, the know-how and the engineering and the rest of the system to have confidence that it's going to work well. But I think, when we're talking about most kinds of use cases for flow batteries, the electrolyte's actually about 70% of the total cost. It's really, really big, right? It's not like, I've just invented one tiny component in a lithium-ion battery and trying to commercialize that, but it turns out to be maybe 2% of the cost of the total battery. This is like definitely well in the majority of the cost, where able to just focus on perfecting our product and then working with everyone else to get our liquid into their tanks. And that really has saved us a lot of time and money.
No doubt about it. And time and money, you're checking those two boxes, you're doing something right.
Yep. For a startup especially, right? Time and money are critical. So I'm happy that we are able to do this with a lean team.
Yeah, absolutely. There's been some skepticism historically around new battery chemistries, making it from lab to really long-term field performance. And we haven't seen, the kind of major breakthroughs a lot, if we rewind to history. But how do you think about this and just proving reliability at scale?
Yep. No matter what, we have to have a field pilot. So that's exactly what we're working on right now. We're 100% in execution mode. We're building a field pilot in India. That will be the first one actually, and it's going to be operational in the second half of this year. And as well, we've got a 5 megawatt hour battery that's been generously funded by the Department of Energy, the California Energy Commission. This will be basically serving a hospital medical center in Lancaster, California, near Los Angeles. But in both of these cases, we're just using a commercial flow battery system made for some other chemistry and dropping in our liquid into the tanks. So from like reliability standpoint, we're pretty confident that it's going to work because these have already been deployed elsewhere and they're running at the moment without problems. So it's just a liquid change. But at the end of the day, for people to sign the sales contracts, you need to have something you can show them so they can kind of kick the tires, right? You won't just buy a car without test driving it, will you? Well, I think some people might, but I won't.
Me either. Yeah, this just trust in energy infrastructure is built over time and through consistent performance. You mentioned a couple things there, though. You've got this Department of Energy backing these projects and supporting a hospital. You're like, okay, if they didn't see some serious proof in the pudding, you wouldn't go with that. So I think that says a lot in itself of where you are even through that as you're ramping up. So absolutely incredible. So you go through this path, like once performance is proven, the next challenge is translating that into real deployments and a scalable business. And so what does the path to commercialization look like for Quino over the next few years?
Well, we're able to kind of like market two kinds of products. One is we could sell just the chemical to the existing manufacturers of flow batteries. They have their own sales networks. And the other one is for places where maybe there isn't currently a partner. Like flow batteries have been mostly pretty strong in China and the European Union, but less so in the United States. Here, we could also purchase someone else's hardware, put the fluid in tanks, and then sell that on to developers. But, that's like, right now, we just focus on maximizing production volume and deployments. I actually don't really care so much about, we've got to control everything because we've been working with all these OEMs in the background. They know how our things function. They've already got some familiarity with it. And the more we produce, the lower the unit cost will be. And that's definitely going to be a good thing.
Yeah, absolutely. Good thing and exciting to see that scale and grow. And I asked this earlier, I want to revisit it. When you are in this kind of initial period, going through kind of ramp up and commercialization, which initial markets or use cases are really the absolute best fit for your technology today?
That's a great question. We probably want to demonstrate the technology at a place that simply just cannot have anything which is flammable. That's one thing. So the demo system at the hospital in Los Angeles is actually a really good use case because, as you know, like Los Angeles County had these like giant wildfires not so long ago, and now around Southern California and also like elsewhere in California, lots of communities have put moratoria on building new energy storage systems, that are flammable. And so you just can't install lithium-ion anywhere. I don't know if like this particular spot in Lancaster, California does have a moratorium on new lithium-ion, but I know that this is like right next to a residential neighborhood. So they just couldn't install lithium-ion at all. And weirdly enough, this is like a medical center which doesn't actually have backup generators. They don't have backup power, so we're providing that. So it's a really nice from a resiliency standpoint. I think non-flammability is one really big use case in the near term. And then the other one is actually like, repurposing this tank storage infrastructure. I didn't mention this earlier, but like as you're seeing EVs grow in popularity, the demand for fuel additives, lubricants is going down, and it's pretty much unstoppable. the decline is unstoppable. So now you have all this like leftover tank storage capacity. What do you do with it, right? Like it's just an asset which in many cases fully depreciated. It costs money to demolish, but it also costs money to just keep operating and maintaining. So what do you do with it? I think that's one thing that we can come in really, really well on, and no one else can touch. Not even other flow battery chemistries.
Yeah, absolutely. Definitely, you can see sort of those clear paths forward and where it would make sense. Safety, obviously, being a big one when that concern is there, or it's mandated as well too. But yeah, when you look at the whole landscape, right? And I often say like it's an and, not an or. We need multiple technologies, multiple things to help us get here. How do you think about just competing with lithium-ion, other long duration storage technologies? Like, how does it all fit in, and how do you view that?
Yeah, exactly as you said. The demand for energy storage is so large, and the use case is so varied as well, that no one single technology can actually, be the silver bullet, right, for everything. Particularly in, like I said, multi-cycle per day applications and longer durations of storage. I think that's where flow batteries will really shine. And fortunately, we're able to plug into an existing ecosystem of flow batteries, so we can really ramp really fast and like catch a wave at the right time. Going kind of looking forward into the future. Essentially, if you want something which is non-flammable, which is made domestically, which is affordable, you really have to look really closely at flow batteries.
Yeah, absolutely. I think it's a competitive landscape, but one where multiple solutions are going to be needed. I think again, it's those that are in it. You see this future where storage is really at the heart of it, and we're probably going to be storage in every home across our nation and beyond in our future. And this is only going to be more and more and more. So it's important why all these technologies need to exist, and use cases where each are advantageous. But you mentioned a couple things like the Department of Energy and some other partnerships and things like that. How do partnerships, whether it's with utilities, developers, manufacturers, how do they factor into your scaling strategy?
Yeah. So fortunately, like I said, we can sell our electrolyte directly to OEMs. And so, if it's kind of like, I don't want to reinvent the wheel. I don't want to go after like other customers that other people are kind of pursuing already, right? Where, we're able to tap into those sales networks or those relationships that the OEMs already have. And, I'm happy to just provide electrolyte because it means our unit costs are lower. But if in certain markets, we've also had to go out and look for our own customers. And, we're seeing really, really good traction with like people who are asset owners of these big tanks. I think that's something where, some developers have actually identified this as a really big redevelopment opportunity. I can't name who they are, but, I just want to note that there's this like really big battery project in Central California called the Morro Bay project, Morro Bay Battery. And, kind of ironically, that was a fuel tank farm, like a whole bunch of big oil tanks that were demolished so they could build a big lithium-ion battery. And turns out the local town didn't like it at all, and they actually voted to stop the project. So it was just abandoned after they spent all that money to demolish tanks. Well, what? That's such a shame because they could have actually been using quinone flow batteries. But yeah, I think like we don't want to reinvent the wheel, so that's why we're actively looking at opening up new markets, new customers, where we're focusing on tank infrastructure redevelopment. We're working with other developers and other partners, integrators as well, on the kind of traditional hyperscalers and AI data centers. So that one we don't really work with those companies directly, but through someone else who is. Because like AI data centers are very much front and center of everyone's attention, right? But we want to go after like what we think is excellent product market fit for our technology, and which, quite frankly, no one is really chasing after. But they have a real pain point, and like, what am I going to do with all these empty tanks? I can't redevelop the land because it's been contaminated, right? It's like you can't build a apartment block on former gas station, at least not in California. So it's very much the same thing. It's like, what do I do with all this stuff that like no one's using but is fully depreciated? Well, that's where we come in. So I'm seeing really, really strong enthusiasm and good traction there.
Yeah, I love that. And, kind of the dependence on kind of the broader ecosystem and not reinventing the wheel. I think having a simple solution that can fit just in a lot of different use cases, even that kind of like abandoned infrastructure and things like that, where it's just a simple, easy, transition and fit. So I definitely see that helping and aiding your scaling ability and accelerating that as well. As we get closer to time, I want to zoom out a little bit and about where all of this is headed, what it enables at a system level. So as you look at sort of the broader energy transition, where do you see the biggest opportunity for long duration storage to make an impact?
Yeah, I think that it's building up, right? So as you get more renewables on the grid, the need for energy storage gets larger, and not only that, the required duration gets longer and longer. So when solar was in its infancy, like you really only needed maybe 1 hour or 2 hours of storage, and now it's lengthening to 4 hours. Now you have 8 hours, even 12 hours of storage. I think actually you're seeing that most strongly in places like California and surprisingly enough China as well, because there's so much renewables and so much storage coming on the market that the duration, as you shave that peak, right, the base that's left gets wider and wider. So it's just a natural extension of like getting more renewables on the grid. The need for LDES becomes longer. The use cases for flow batteries or longer duration storage is at places that have the most renewable penetration right now, California, because there you have things like resource adequacy payments, like need for resiliency, right, as you get more renewables on the grid. But I also wanted to, as you said, take a step back, and the energy transition isn't just focused on generation and storage, but it's also all about the other things, right? Electrification of everything, like transport as well. We're moving away from internal combustion engines to electric vehicles, and that has knock-on effects on all the infrastructure elsewhere, right? There's transmission, right? There's also like shipping oil products around, like storing them. Well, like I said earlier, if the demand for gasoline or lubricants is going down and it's in terminal decline, then what do you do with the rest of the infrastructure? So it's actually it's really fascinating. It's all interconnected, and we're able to actually, the rise of EVs has actually indirectly propelled Quino Energy's relevance as well. So just really interesting. It's one of those things I never thought of when we were starting out.
Yeah, it's super interesting kind of where it's headed. And I agree sort of the beauty of that, like interconnection, like it's all connected. But it's interesting, like the more you look at it and all these different technologies and these generation sources, like a lot of it still just points back to storage in the middle, and long duration storage has a potential to really reshape how we think about reliability on the grid, especially as more renewable sources come online, as you said. But yeah, it's one of those enabling technologies that unlocks other parts of the systems. It's just cool to see that and watch that evolution happen. What excites you most right now about where Quino is headed, about where they are now, and then what's coming next? Like,
yeah, at my heart, I'm a scientist. I'm an inventor. So I just really geeked out by seeing something that I worked on in the lab, like get scaled up multiple orders of magnitude and make it into a like working product that's actually functioning. And I'm just really excited for our demo projects coming out really soon, and also the factory. Like when I was working in the lab, like I thought, making a couple grams of this was a big accomplishment already, and now we're talking about easily 1,000 tons per year, and that's like 9 orders of magnitude. That's crazy.
Yeah, it's got to be a really special feeling, like to see it from like, in the lab and these kind of like really small batches, and you're like, that's a win, and then seeing it get to the level it is, and then what's going to come after that too. So yeah,
it's a really great feeling. It's like just very satisfying. I'm a scientist at heart, right? So I just like seeing the ideas that you have get translated into something that's out there in the field and operating, at a really big scale.
Yeah, I love it so much. Thinking about just the company as a whole, what do you want people to know about Quino, like where you are now, where you're going to be, what they should be thinking about, or if anything else you would love for just listeners to know and understand about your company, what you're doing?
First thing is we are always just going to be partnering with all these OEMs, basically. So Quino Energy will remain a small, nimble, highly innovative company, but we couldn't do it without the help of all our friends and partners elsewhere in the ecosystem, the flow battery ecosystem. That's one thing. The second is the innovation is still going on, right? We've got something and we're scaling it up, but we're always improving. And finally, it's just been a really fun adventure to be able to just talk to people from all over the world and see how our technology, which started out in the lab, can be of relevance to so many people, so many markets.
Absolutely. I'm sure, I love talking with people all over the world and different perspectives. And and different thoughts, and you see what people are doing right, and you learn from it, and it's just cool, like having that element of it as well too. So I love it. Love to see these new technologies kind of coming up and going and scaling. And we'll continue to feature these as well as we go. I love it. So final words, anything else to share with the audience? Any other kind of words of advice, wisdom, anything you didn't get to share that you'd like to?
Well, I did also want to say, so we use quinones in our battery electrolytes, and they're pretty safe because my guess is if you ate some broccoli earlier today, you probably ate some quinones. And if you're wearing like anything which has any color, you're probably wearing some quinones too. So they're nothing to fear. They're everywhere. You just haven't realized it. So I would like more people to know that there are alternatives to lithium-ion battery or sodium-ion batteries, which have captured the news. If you want something which is made locally, you want something which is completely non-flammable and still pretty affordable, there are alternatives out there called flow batteries.
I love it. A great way to just kind of wrap that up, and we'll put a bow on it right there. I love that. Just the simplicity and the connection. I'll add some links as well in the show notes too, if anybody wants to go check out and continue to learn. But Eugene, this was a fascinating conversation. I really appreciate you taking the time to walk through both the science and what it takes to bring something like this into the real world, explaining it in very simple ways that we can follow as well too. To everyone listening, if you enjoyed this episode, make sure to subscribe to the show, leave a review, and share it with somebody thinking about the future of energy. With that, we will see you next time.
This episode of Green Giants, Titans of Renewable Energy, was brought to you by Lee Group Search. If you enjoyed today's discussion and are looking to recruit top talent for your company or find your next career opportunity in the renewable energy sector, visit leegroupsearch.com. Let's continue driving the future of clean energy together. Until next time, keep pushing toward a greener future.